Aluminum is one of the most important, valuable, and useful metals. The common form of aluminum that you might know of is aluminum foil, or aluminum used in tins, cans, pots, and pans. But aluminum has a variety of uses, ranging from electronics to automobiles. Aluminum is one of the most abundant metals on Earth, making its usefulness more effective. The problem, though, is that aluminum does not occur naturally as a metal. It can commonly be found attached to silicon atoms in soils, rocks, and bauxite minerals. In this lab, we explore some important chemical properties of aluminum. Because aluminum contains a very thin oxide layer around its surface of the metal, it is often misconceived as unreactive. The following experiments attempt to explore the reactivity of aluminum as that oxide layer is removed. In experiment 1, the aluminum shots are very slow to react with hydrochloric acid. Slight bubbling can be noticed upon the surface of the metal, and if left long enough, a reaction will occur. In this next experiment, we compare what happens when we remove the oxide layer, previously protecting the aluminum from the hydrochloric acid. By heating 2 samples of aluminum shots with hydrochloric acid, the removal of the oxide layer is sped up. By washing one sample with water after removing the acid, the oxide layer is allowed to reform once again, producing that protective layer. Aluminum metal quickly reacts to the oxygen in air to reform that aluminum oxide layer, making the metal seem unreactive. The results when comparing the two tubes clearly shows that the tube of aluminum that was rinsed is less reactive, producing less fizz than the tube that was not rinsed with water. Mercury chloride is a strong oxidizing agent that helps to remove the aluminum oxide layer and reacts with the aluminum metal. This then produces more aluminum oxide as more metal is exposed, and some of the mercury reacts with the aluminum to form an alloy. The amalgamation reaction is a repeated cyclic process where metallic mercury is being produced and the aluminum metal is being eaten away, producing more aluminum hydroxide. The reaction is highly exothermic, and aluminum reacting with mercury can be very dangerous. This is why mercury is not allowed on planes. The next step, the metal is removed and then submerged in more hydrochloric acid. Strong bases like sodium hydroxide attack amphoteric metals such as aluminum, creating hydrogen gas and a very strong exothermic reaction. By reacting aluminum with mercury chloride, we can once again see what happens when that amalgam is formed. The exposed aluminum continues to react with oxygen in the air, forming aluminum oxide. The aluminum foil then begins to disintegrate into a gray powder, as if though Thanos came from a Marvel movie and snapped his fingers. The reaction is very exothermic. Aluminum hydroxide is produced by adding ammonia solution to a solution of aluminum chloride. This experiment aims to explore the amphoteric properties of aluminum. Ammonia is added to the aluminum chloride solution, forming a white precipitate. That precipitate is then shared between 3 tubes to do the test. In Tube 1, we explore how the white precipitate of aluminum hydroxide is dissolved by adding sodium hydroxide. Aluminum hydroxide will readily dissolve in strong acidic or basic conditions, but not in the presence of a weak base such as ammonia. In the final tube, the aluminum hydroxide is dissolved with hydrochloric acid. Anhydrous aluminum chloride is very difficult to store, especially in Belize's humid climate. Notice as I open the bottle, you can see some smoke coming off. Although I have the bottle in another container with a plastic wrap, this still does not prevent the reaction from occurring. The white gas being produced is actually hydrochloric acid being formed as the gas reacts with the water in the atmosphere. Heating anhydrous aluminum chloride, it actually undergoes a sublimation. As you can notice, the volume of solid inside the tube reducing as more hydrochloric acid is produced. Sodium chloride, on the other hand, does not undergo decomposition or sublimation upon heating. At most, at extreme heats, sodium chloride could then form a molten version of the salt. In this experiment, the pH of hydrated aluminum chloride is tested using pH paper. Aluminum chloride reacts with sodium carbonate to produce aluminum hydroxide, carbon dioxide, and sodium chloride.